So we can use the enumerated type controls to give users a list of items from which to select. An enumerated type control or enum is similar to a text or menu ring control in that both controls list of strings through which we can cycle. However, enumerated type controls differ from ring controls in 6 ways. Number one, the data type of an enumerated type control includes information about the numeric values in the control and their corresponding strings. The data type of the ring control is numeric only. Second, the numeric representation of the enumerated type control is an 8-bit unsigned integer or 16-bit unsigned integer or 32-bit unsigned integer, while a ring control can have from unsigned 8, 16, 32, 64 to signed 8, 16, 32, 64 to single precision, double precision and extended precisions also. The only four that it cannot have are the fixed point and these complex types. So we can right click the type of control and select representation from the shortcut menu to change the representation of the control. The third difference is that we cannot allow user to enter undefined values in enumerated type controls. No such option is available here, while with ring controls such option is available. So we cannot allow the user to enter undefined values in enumerated type controls, and we cannot assign specific numerical values to items in enumerated type controls. If we need this functionality, we should use a ring control. The fourth difference is that we can edit the items of an enumerated type control only at edit time, while we can edit ring control items at runtime using the property node. So if you want to change the let's change it to change to right. Let's create a constant which is an array of strings, so let's fill them up. Let's open up few more items. So if I go to the front panel, run this VI, so you can now see that the text have changed. But if I try to do the same with Enum, you will see that LabVIEW will report that an error occurred at property node. This property is writable only when the VI is in edit mode, or this method is available only when the VI is in edit mode. Property name is strings, so you cannot change the strings of Enum at runtime. So the fourth difference is that when we wire an enumerated type control to the selector terminal of a case structure, LabVIEW matches the cases of the string values of items in the control, not the numeric values. So let's see. So if I connect Enum, you can see that the text is present, is shown in the case structure. But if I place another case structure, but this time connected with a ring, then only the numbers associated with those strings are shown. When we use a ring control with the case structure, LabVIEW matches cases to the numeric values of items only. And the last difference is that when we wire an enumerated type control to the selector terminal of a case structure, if we go to the front panel, you will notice that there are 3 entries in this Enum, first, second and third, while only 2 are shown in this case structure connected to it. To show all values, right click the case structure and then select add case for every value, and then all values will be shown. So we can right click the structure and select add case for every value to create a case for the string value of each item in the control. However, when we wire a ring control to the selector terminal of a case structure, we must manually enter each case. There are 3 values in this Enum with associated numbers 0, 1 and 2, but only 2 are shown here. So if I right click, then no such option like add case for every value that option is not available. I will have to add the case for value 2 manually. All arithmetic functions except increment and decrement treat the enumerated type control the same as an unsigned integer. Increment changes the last enumerated value to the first value, and decrement changes the first enumerated value to the last value. So let's remove these case structures and clear the broken wires. So let's find the value. Let's place an increment. And then let's place a local variable. Let's go to the front panel, and if the last value is selected, which is third, and I press run button, then it will be incremented by 1 and the first value will be selected. If first is selected, run the value, then second will be selected. If second is selected, then by incrementing, third would be selected, and if third is selected, then this code will cause it to revert back to the first one. So let's change this, replace it with the decrement and see how that behaves. So if the first value is selected and we decrement it, then the last one, third one, would be selected. If third is selected, then decrementing it would select second. If second is selected, then decrementing it would select first, and if first is selected, then decrementing it will take us to the last. It's like circle. When coursing a signed integer to an enumerated type, negative numbers change to equal the first enumerated type, and out of range positive numbers change to equal the last enumerated value. So let's go and check. So we have, which is an integer. So let's add some negative value and connect this to the enum. If we run the code, then the first value should be selected, which is 0. If I remove the negative sign, there are only 3 values in this enum, 0, 1 and 2. So if I go beyond that in positive terms, then the last one will be selected. Out of range unsigned integers always change to equal to the last enumerated value. So if we change this to this representation, if we change it to unsigned, then we cannot go to, obviously, to the negative numbers. So if we go beyond what are the contents of this enum, which are 0, 1 and 2, so if we send 12 to it, then it should select the maximum that it can, which is the number 2, which is associated with value third. If you wire a floating point value to an enumerated type indicator, LabVIEW courses the floating point value to the closest numeric value in the enumerated type indicator. So if I wire, change the representation to, let's say, double, and then I send 1.2, then 1 should be selected, which is value this one. This is 1, this is 0, this is 1, this is 2. So if I select 3.9, which is beyond what is which is the last value of this enum, then we should have the last one selected. If I select, suppose, minus 1.2, then the first one should be selected, which is 0. So LabVIEW handles out of range numbers, as we have discussed a few moments before. If we wire an enumerated control to any numeric value, LabVIEW courses the enumerated type value to a numeric value. So let's connect this to a numeric indicator. So this value is going now into this indicator. So if we select first, then 0 goes. If we select second, then 1, and if we select third, then 2 goes into the numeric indicator. To wire an enumerated type control to an enumerated type indicator, the items in the indicator must match the items in the control. However, the indicator can have more items than the control. So let's remove all these, clean up the wire, and create an indicator. Create indicator. By default, LabVIEW creates the indicator that has the same elements. So if we select any value from this, run the VI, then the same value is shown here, and though LabVIEW doesn't report any problems. So if we add a new value, let's say then LabVIEW does not report any problem. But if I change this value, then LabVIEW reports an error and the wire is broken. So let's see what problems LabVIEW reports. LabVIEW says that wire enumerated conflict. You have 2 or more enumeration data types wired together, but the enumerations are different. The list of items in the enumerations must be exactly the same. When using enumerated type controls, we should always make a type definition of the control. So let's remove all these things. And we can make type defs by using make type def. And a small rectangle, black rectangle on the upper left side indicates that it is a type def. So when using enumerated type controls, we should always make a type definition of the control. Creating type definitions prevent us from needing to rewrite the code each time we add or remove an item from an enumerated type control.